Hello friends, how are you? I hope you are well. During vacation time, especially in summer vacation, Dasara and Sankranti holidays, several times I have travelled either from Hyderabad to Cuttack, my hometown, or from Warangal to Cuttack. During my travelling, I used to carry my hot food with aluminium foil cover. By wrapping my food with aluminium foil, I used to carry. What is the reason? I hope that you all are excited to know the reason behind it. Yes, the reason I shall expose through Stefan Boltzmann law. Generally, there is a misconception that heat flows from a hot body to a cold body. Hot body to a cold body. Sorry. In fact, it is not correct. Then what is correct? All bodies can emit thermal radiations at any temperature. So I can say that all bodies can emit thermal radiation at any temperature, above absolute zero, irrespective of nature of the surroundings. That means I want to say that heat can flow either from hot body or to cold body, does not matter. All bodies can emit thermal radiations or heat any temperature, but it must be more than absolute zero, because in the earlier video I have explained that at absolute zero molecules are completely seized. There is no kinetic energy, there is no vibrations, there will be no temperature. So if the substance temperature is more than absolute zero, there will be a emission of radiations. So already you know that electromagnetic radiations can travel long distance without any medium. Now, suppose two bodies at different temperature, they are in thermal contact. See here, suppose this is a hot body, this is a cold body. Both are in contact, thermal contact. Heat can flow from hot to cold, or it can move from cold to hot. But you can say the net heat flow from hot body to cold body, there is no doubt. Net transfer of heat energy is from hot body to cold body, but transfer made from hot to cold or cold to hot, at a time it may take. But net transfer of heat energy or thermal energy, we can say from hot body to cold body. So our misconception that heat flows from hot body to cold body, that is misconception only. So the real fact is that heat can flow either from hot or from cold if the temperature is above its absolute zero. Now let us consider one black body which is a perfect observer and perfect emitter of thermal radiations. Suppose this is a black body which is a perfect observer and perfect emitter of thermal radiations. For example, it is emitting the radiations in different directions. The amount of radiations coming per unit time, or I can say that the rate of emission of thermal radiations, the energy emitted per unit time, it depends upon its size, it depends upon its area. How much heat energy it will emit, it depends upon its surface area, it depends upon its temperature, it depends upon its emissivity, its ability to emit the radiations. Different substances, its ability is different. So the amount of radiations per unit time, I can say that the amount of thermal energy emitted per unit time is directly proportional to surface area of this black body. If the area is more, the rate of radiation, this is the rate of radiation, rate of radiation, this is directly proportional to area. I can say that this rate of radiation is directly proportional to fourth power of the temperature in Kelvin scale. From the experiment, it is proved that the amount of radiations per unit time is directly proportional to fourth power of the temperature in Kelvin scale. If I combine these two, I can say that 8 to the power 4, or I can say that H equal to rho 8 to the power 4. This is Stefan Boltzmann law, or this rho is called Stiffness constant. This is Stefan Boltzmann law. In fact, Stefan and Boltzmann, two persons. Stefan suggested the law on the basis of experimental data available with him. He suggested the law, but the derivation of the law was made by another scientist, Boltzmann. That's why we study it by the name of Stefan's Boltzmann law, and this rho is a Stefan's constant. So what is the value of this rho? This rho value is 5.67. This rho is equal to 5.67 into 10 to the power minus 8 W per meter square per Kelvin to the power minus 4. This is the SI unit of Stefan's constant. What I have written in the form of sigma. Sorry, I said rho. In fact, the sigma. I have written sigma for the Stefan's constant. So, suppose the body is not a black body. For example, the body is not a black body. If it is not a black body, then the rate of emission will be equal to E rho A T to the power 4. Here is called emissivity. If it is not a perfectly black body, I shall use E. E stands for emittivity. For a black body also I can use this equation. For a black body, this emissivity is equal to 1. So in place of E, if I use 1, then it is equal to rho A T to the power 4. And this value of E, actually it varies between 0 and 1. If it is a black body, it is 1. If it is for a reflector, for a perfectly reflecting body, this value of E is equal to 0. That means this E lies between 0 and 1. Maximum 1, minimum 0. For a perfectly reflecting body, its E value is 0, whereas for a perfectly black body, this value of E is equal to 1. So, we got two equations. I have written there H equal to rho A T to the power 4. This is one equation. Second one, I said that for any substances we can write this is E rho A T to the power 4. This is the second equation. Listen carefully. It may not be a perfectly black body, no matter, but the rate of radiation will be directly proportional to fourth power of the temperature in Kelvin. It may not be black body, does not matter. All bodies, the rate of radiation is directly proportional to fourth power of its temperature. That is why it is also called Stefan's fourth power law. What we call generally Stefan Boltzmann's law. So, now listen carefully. So, I can say that this E of a body, this is E of a black body, is equal to its absorption power, So what is this E? E is the emission power. Here E stands for the emission power. A stands for absorptive power. So, A for the absorptive power, E for the emission power. So, this is for the any substance, this is for the black body. Now, if this emission power is directly proportional to rate of emission, I can say that emission power is directly proportional to rate of emission. So now I can write that, suppose the second equation I shall divide by first equation. E rho A T to the power 4 rho A T to the power 4, both are directly proportional. This is equal to A, implies that E is equal to A. That means the rate of emission and rate of absorption both are equal. It proved that E equal to A. This one cancel. So this A E left, this is A. I said this emission power is directly proportional to rate of emission. So equation 2 I have divided by equation 1. I got the E. That is also equal to absorption power. So rate of emission is equal to rate of emission. Now let us consider a body is in thermal equilibrium in a room. Suppose a body is in a thermal equilibrium in a room. Consider a body is in thermal equilibrium. A body is in thermal equilibrium in a room at temperature T naught. So the body can absorb the energy or it can emit the energy. The amount of energy absorbed, the amount of thermal energy absorbed per unit time is H equal to, I can write that, E rho A T naught to the power 4. Similarly, I can say that the amount, but the thing is that the temperature of the room constant. The temperature of the room is constant. So the amount of energy I have written absorbed for a unit time is E rho A T naught to the power 4. For example, the temperature of the body became T. Suppose temperature of the body now it is T. Then I can say that energy emitted per unit time H equal to E rho A T to the power 4. So I can mention it is H naught. I can write it as. Then the net loss of thermal energy. The net loss of thermal energy, I can say that delta H equal to this one minus this one, E rho A T to the power 4 minus T naught to the power 4. This is the net loss of thermal energy. So from this we understood that the rate of absorption is also equal to rate of emission. In the starting of my video, I said that why did I used to carry the food with aluminum wrapper. The fact is that the emissivity of the aluminum is very less. The emittivity of the aluminum. The emissivity of aluminum is very less. It is very less than 0.1. That means its heat emitting capacity very less. That is the reason I used to carry my food through this aluminum foil. I hope that you might have understood the concept of Stefan Boltzmann law very well. So in the next video, we'll discuss the other concepts of the topic. Until then, bye. Thank you.